The first step in designing data center after finalizing the location is calculating its power requirement.
Because it is what makes all of the data centers technology function, and if the power goes out, then all of the technology is useless.
So watch the video till end to make a right calculation of power load for your data center design, because an ideal data center needs ideal power load.
So this is Pranav,
And this is Nitin,
and we welcome you to the new episode of
D4 Data Center by MSP TV. In today's video, we will share how to calculate the power requirement for the new data center, or if you are upgrading the existing one.
But before we begin, please hit the subscribe button and press the bell icon so that you don't miss any update, and also to support our channel.
So let's start. Calculation of total data center power is actually quite straightforward, but it gets complicated when it involves redundancy and the future load that we might be at.
Power calculation needs to be as accurate as we can get, because if we underestimate the power requirement, it can lead to the insufficient function of data center and also cause disruption in the future.
On other hand, if you overestimate your power requirement, it can add to the excessive initial investment and leading to the higher maintenance cost in the future, because the data center will be not good energy efficient.
So the more accurate your calculation is, the more energy efficient your data center is.
To accurately calculate the power, first you need to know where the power is going in the data center. Majority of the power used in the cooling, that is 50%, and the next is critical load. They takes 36%. We will explain what is critical load in our later part of this video. Moving 11% off for the UPS, inefficiency, battery charging, and the 3% is a lighting load, which many data center designers ignore, but precise we would take into consideration.
Let us understand calculation with an example of a hypothetical data center which is about 5000 square feet, and it will have 200 racks, and half which will use direct expansion or air cooler and half will use water based cooling. Cooling is a much bigger topic that we will cover in our upcoming videos.
Now, based on this hypothetical data center, first let's determine the size of critical load, the one that mentioned in earlier. So what is critical load? The power used for servers, routers, storage device, telecommunication equipment, security system, fire monitoring system, all these forms are a critical load, because they are critical devices of our data center, and these devices need to be up all the time.
Now, once you have made list of the devices, first note down the power rating of these devices, their voltage requirement, whether it's single phase or three phase. We need to know this beforehand to design efficient power system according to the equipments we have.
Let us calculate the power now by putting this into table, and we need to calculate this on each rack basis, assuming that all the racks in the data center will be the same. Now for the example, we will calculate two servers with a power rating of 300 watts and 400 watts, which is consume 0.3 kilowatt and 0.4 kilowatt of power respectively. Two storage array with a 500 watts and a 310 watts with a consumption of 0.5 kilowatt and a 0.3 kilowatt respectively. When we sum up the total power, we get 1.5 kilowatt power consumption in a single rack. Now we multiply with the total number of racks in the data center. We will get it 1.5 kilowatt racks into 200 racks. That is total 300 kilowatt load. Right, keep in the mind this just critical load. We need to calculate even further.
Wait, this is not over yet. The critical load that we have calculated is for now. You need to also calculate the load for peak time. In simple word, when your data center is used at full capacity during that time, power consumption is very high and you need to have additional power for that. Also, what about few years down the lane? Once the business expands, you need to scale up the data center as well, because then you cannot just go for additional power without having the systems that can take that load.
For that, let us take our calculation further and first calculate future critical load power. Let us assume that we will scale our data center by 20% after few years. So with our calculation of 300 kilowatts critical power, we need additional 20% power down the line, which will be 60 kilowatt. This is 20% of 300 kilowatt. So now total critical load is 360 kilowatts. With the total critical power load, now let's calculate the peak power adjustment that we would need during the peak consumption period. On general, we give 5% overhead for the full maximum usage. Now we will calculate our peak power multiplier would be 1.5, so our peak power drawn will be 360 into 1.05, which is 378 kilowatts. Now by subtracting the critical load from the peak power drawn, we will get the peak power adjustment, which is 378 kilowatt minus 360 kilowatt, which is 18 kilowatts.
Now you have critical load and peak power adjustment, keep them noted, and move to the next calculation, that is UPS load, which is also a very important equipment for a data center. Here the key factor that comes into play is how efficient your UPS is. Let us assume that our UPS is of best in class and it is 90% efficient, which means if 100 kilowatt of power goes into the UPS, 90 kilowatt comes back, leading to 10% inefficiency, meaning 10 kilowatt of power is used with UPS and it's lost. Now with 10% is UPS inefficiency, and in general UPS needs 20% power to charge its battery if it is partially or completely discharged. So now summing this two gives power load required for UPS, which is 30% of critical load, which is 360 kilowatt. So the 30% of 360 kilowatt is 108 kilowatt. This is your total UPS load.
Now moving on quickly, let's calculate the lighting load. Estimating it will be 2 watts per square feet. So its example, we have a 5000 square feet, so it will be 10 kilowatts lighting load. Now let's add up all that for the total power load. So our critical load is 300 kilowatts, future load is 60 kilowatts, peak power adjustment is 18 kilowatts, UPS and battery is 108 kilowatts, lighting load is 10 kilowatts, total power load is 496 kilowatts.
Now with total power load required, we need to calculate the power load required for cooling this load of our data center. As we said earlier, for our example, 50% of the cooling will be direct expansion and 50% chilled water, which means 248 kilowatt of our total power will be cooled with DX and 248 kilowatt with chilled water. With cooling efficiency facts, we will be able to calculate the power load that we need. Since chilled water cooling is very efficient, the power required, it will be 70% of the load to be cooled, which is 248 kilowatt into 0.7 is equals to 173 kilowatt. This is required for water cooling. And since direct expansion is not that efficient, the calculation will be 248 kilowatt into 1, which is 248 kilowatt. Summing this, the total cooling load is 323 kilowatt.
Now we have done our calculation. Let us look at the total power requirement of our data center. So our critical load is 300 kilowatts, future load is 60 kilowatts, peak power adjustment is 18 kilowatts, UPS and battery is 108 kilowatts, lighting load is 10 kilowatts, cooling load is 323 kilowatts. So total power requirement is 819 kilowatts. Now the numbers are getting little big, right? It will be slightly even bigger. We cannot say our power supply that we need 819 kilowatt because at any given point in time we cannot exceed 80% of our total power supply. We need to keep 20% over according to the electric code of the data center. Therefore, we need to multiply the total power into 125%, which is equal to 120 kilowatt. In general, we need to buy 4 times of power we need. Yes, it might be look too much, but this is the process of calculating the power requirement.
Well, congratulations on your perfect calculation, but wait, there is a last step also. For any data center to run completely without downtime, there needs to be a standby generator, because what if there is a power outage? Therefore, you need to calculate the power to know how big generator you need. Don't worry, it is very simple. Here, the generator is needed for different stages. First for critical load and the second for cooling. Because if you have low density data center, you can choose not to use generator power for cooling. So, for generator required for total power load excluding cooling, that is 495 kilowatt, multiply it with 1.3 is equal 645 kilowatt. So we would need a generator with capacity of 645 kilowatt for key equipments. Now if you need for cooling also, multiply your cooling load with 1.55 times. In our case it will be 323 multiplied by 1.55, which is 501 kilowatt power generation.
So this is it, guys. This was the step-by-step method of calculating the ideal power load for ideal data center. If you are still finding difficult, take the help of professionals like us.
We have good experience in calculating the power consumption of data centers. If you have any questions about power consumption, please feel free to contact us anytime at info@msplgroup.com.
And if you like this video, please like it below and share with your friend who might find this useful, or with someone who is interested in data center.
Don't forget to subscribe to our channel and to press the bell icon to receive notification. If there is particular topic about data center or any other query that you want us to cover in our upcoming videos, or any suggestions to make our content more interesting, please feel free to share it in the comments below or email us to info@msplgroup.com.
You can also connect with us on Facebook, Instagram and LinkedIn for the updates. Also do visit MSP Web Store, our online store for the power backup solution for home, offices, also for the accessories related to data center.
Well, that is it from us for today. Thank you for watching this video till the end. Take care of yourself and your loved ones. This is Nitin along with Pranav signing off. See you soon.